All right. Awesome. Thanks for having me here again. And I'm excited to speak about this. This is some of the work that we've been doing in the recent past, and it's about analogies, common sense knowledge, and how there's always a space for that in explainable AI. And I hope I'll make that case by the end of this next 20 minutes or so. I'm not going to go ahead and introduce myself further, but thank you, Michael Soprano. I think I pronounced your name
Definitely.
As you did mine. All right, so I think we'll all agree that this, at least from one perspective, can be viewed as the golden age of AI, right? And bear with me. If we do, I'd argue that most explainable AI work has so far focused on the tip of this metaphorical iceberg, also why I painted that iceberg gold. And although the letters HCI don't quite exist in the space of XAI, my argument here is that explainability in AI is as much of an HCI problem as it is an AI problem, right? Yet the human side of this equation is often lost in technical discourse in the space of explainable AI. And I'd like to try and bring a perspective to the fore where that can be quite costly. And I want to argue that this human lens is a very valuable one for us not to forget. To dive into the crux of the matter, present-day explanation methods have focused on creating an understanding of what models are basing their decisions on, right? So this is, or you can think of this as communicating what models have more or less relied on for predictions. So take your classic feature attribution methods and the likes. But what's really been missing, in my opinion, is truly trying to explain this to end users in a manner that's actually intelligible, right? So we focused a lot on getting the fidelity of explanations right, which is, hey, how exactly is this representation that of what models have based their reasoning on, right? And only now have we begun to think about the end users who are eventually the consumers of these explanations, right? And quite often we joke with one another now in these circles of explainable AI, who exactly these explanations are for, are they even needed, right? But maybe that's one of the fundamental questions that we often need to think about. So consider this example on the slide where there's an image of a horse, and we aim to make sense of this image that was predicted as a horse and understand what exactly is the machine rationale for this, right? And that's what your interpretation or explainability methods in the space of explainable AI can help you do. So you can get these nice looking heat maps with feature attribution methods and LIME and SHAP and other such techniques to create visualizations that can then allow you as a human to reason out about the accuracy, whether or not this prediction is for the right reason or the wrong, right? So as we went on to propose in this work, this was work published at CACW a couple of years ago, we can then also use human intelligence and crowdsourcing to construct this average notion of what the competing human understanding of this image is and what the rationale should thereof be, and then compare this to the machine rationale and draw inferences as to what potential model errors exist, what are the blind spots that exist in these models, and also whether or not certain neural network models are more congruent to human reasoning and human understanding than some others, right? Why is that useful, you might ask? It's probably useful because when it comes to model adoption, or even adoption of AI systems, right? If you were to extrapolate and abstract at a higher level, systems that reason a lot like humans are easier to understand and adopt than those which are complex, right? So people attribute more trust and credibility to those systems. Whether or not is right is another discussion to be had, but that's essentially how human behavior works, right? Another example from some of our recent work where we looked at a scene recognition task. And of course, you can look at what exactly are model errors by using such explainability methods that exist, try and use human intelligence to augment what we understand is either correct or incorrect so that we can then take this back in the loop. But let me take you back to that notion of explaining all of this complex spaces to people who are probably not all that well versed with technical artifacts, right? So take a layperson, for example. And I don't have to come up with a bunch of different contexts where this is applicable. I'm sure we've all seen medical domain examples floating around, and we do observe and understand the need to be able to explain something that a layperson can understand in a manner that can actually help amplify their decision making, right? Because the big idea of AI here is to try and make human lives better. But if we forget the fact that there is a human at the other end, and we leave it alone with, hey, here's a nice explanation, this explains what the model has based its rationale on, then you're not fulfilling this need of making sure the end user fully understands this part, right? And that's where I'd like to paint the contribution of this work we're trying to put together. This was actually something that sparked off an idea when I read this book a little while ago. It's called Surfaces and Their Senses by Douglas Hofstadter and Emmanuel Sander. Brilliant book. They talk about and argue for how analogy is the fuel and fire of all thinking, right? And it got me wondering, we as humans often tend to explain things to each other using analogies, right? When I'm sure all of us here have had some experience with teaching. Some of us are probably going to have some experience with teaching. All of us most certainly have been students in classrooms before, right? And I'm 100% sure we've all been at the other end of analogies being thrown at us to help us understand complex things, right? So imagine a teacher trying to explain a concept in grade 7 by using things she knows she taught you in grade 6, right? Now, what exactly is that analogy? An analogy is a structural mapping of a target domain that needs to be clarified, right? So think of it in this XAI context as maybe a system accuracy that you want to explain to a layperson, maybe my grandma, right? But you want to explain this by taking that target domain and clarifying it using a source domain which the recipient of the analogy is more familiar with. So I could probably try to draw an analogy to the cooking domain, which my grandma is one heck of an expert in, right? So how can we use this instrument to try and improve intelligibility of XAI problems in spaces, whether it's local predictions or a global system level performance for lay people, right? So we've done a little bit of work in this space, and just walk with me to assume the fact that this can be impactful, right? Because in the rest of this talk, I'll talk about how we can generate these analogies. But before I do that, just to give you an idea of why this could be useful, think about appropriate reliance on AI systems, right? One of the reasons why you want people to fully understand how models are making decisions and leading towards these predictions, that's quite fundamentally important, because the more you understand about it, the more you can make a meaningful choice as to whether or not to rely on it, right? And much like we've discussed in the previous talk, where human biases and cognitive biases shape up in influencing how we behave, that holds with generally any decision-making task that we might want to think about, right? Now, it's our responsibility, therefore, to empower end users to make the right choices, not to over-rely on an AI system, which can then sometimes be wrong and therefore lead to undesired consequences, but also not to under-rely on the system in a manner that would affect you from losing out on the potential benefit that you can gain, right? Now, here's a couple of small examples of what an analogy could be. Imagine you're just trying to explain the system accuracy, right? And you could probably tap into prevalent common sense knowledge, maybe things like people getting onto the fact that AstraZeneca vaccines are only 75% accurate these days, or whether, if you're living in a particular region and you have a sound understanding of how punctual a particular train is, right? Maybe if you're in Germany, you know that there's going to be a delay. And if that's the sort of punctuality or reliability you want to associate with a machine, that might give you an inclination of how, the extent to which I must rely on it without truly understanding what 75% means, right? So there's been a bit of work we've been doing in that space, also related to mental models. And we find that there is some merit in this notion, right? It always sort of depends on the context and depends on when it can work, but there's some merit in this. So how exactly can we go ahead and create analogies? And where exactly is it that lay people can benefit from this? We've addressed this in one of our upcoming papers that will be presented at the HCOM conference later this year, so a month from now or so. But look at this example over here, right? We have concept level explanations, which are, well, pretty much state of the art these days when it comes to a lot of natural language processing tasks. Here's an example where there's an input sample, and you have a complex neural network model, black box, that spits out a prediction saying, wait, this sample has tested positive for prostate cancer, right? And you probably have a layperson who'd like to make head and tail of this And he's presented with this concept level explanation, which is the target sentence. And this says, well, with cribriform and fused glands and needle core biopsy from the prostate, this has been diagnosed as being the adenocarcinoma of the prostate. I don't know about your interpretation of this, but for me, that was all kinds of Greek and Latin, right? Now, how exactly can I try and make something meaningful out of this through analogical inference in a way that a layperson can still, work with this in terms of interpreting it or reacting on it or simply understanding it? Note, for example, none of us here probably fully understand the internal combustion engine in airplanes or all the meticulous details that go into the construction of aircraft, but we're very happy quite often to take these airplanes nonetheless, right? So there is this trade-off between wanting to explain everything and how much a person needs to know in order to be able to use it and benefit from it, right? So here's what we propose. What if we could use an analogy-based explanation where you say cribriform and fused glands and needle core biopsy is definitely a sign of prostate cancer. And this is like recognizing a unicorn due to the horn in its head, right? So you're sort of trying to attribute the fact that there are a couple of things that were detected, which are essentially, significantly indicative of the fact that this is prostate cancer. Much like a horn on a beast's head is, significantly indicative of that being a unicorn, right? Great. So what exactly did we go ahead doing? We first looked at trying to cast a couple of research questions, right? It's one thing to create analogies, but how do we know it's a good analogy? So we said, well, how can we systematically assess the quality of analogy-based explanations? And how can we generate such high-quality analogy-based explanations that do not require expertise? Our approach towards getting to the bottom of the first question, thanks to the fact that there's been a truckload of literature in the space of analogies, was to try and synthesize different dimensions that different works have contributed towards analyzing and speaking about, right? So we tried to synthesize all these different dimensions and come up with a nice little set of dimensions that could help us assess the quality of analogy-based explanations. We then looked at how we could potentially use crowdsourcing as a means to generate this at scale without requiring expert intervention. I can't go too much into the details because of the fact that we have limited time. I encourage you to take a look at the paper, which is also readily available in the form of a preprint. Here's the set of dimensions that we eventually synthesized from existing literature. There are dimensions like structural correspondence. There are dimensions like transferability, which refer to some of the analogical properties of the analogy itself. So how transferable is it from one context in which you're using it or generating it to another context? How syntactically correct is it? How factually correct is this analogy-based explanation? What's the simplicity of the analogy? Is this something quite easy that people can understand, or is it more complex and requires some depth and knowledge? So we identified a bunch of different dimensions, and we also used a questionnaire that we could pose to participants in the follow-up work where we're trying to generate analogies and evaluate them so that we could understand and get a sense of how each of these dimensions was scored on the analogies that were created. Speaking about which, I come to my part B of it, which is how do we generate these analogies? We used a couple of seed tasks where we considered two distinct data sets, right? So in this calorie-related data set, there were two labels. One of that was a low calorie and the other one was a high calorie. The distinction being the amount of fat that was present in both of these, in the images, right? And on the right-hand side, you see a picture of the places data set. And in case of the places data set, we had 6 labels: the living room, I think we had conference rooms, we had hospital rooms, bathrooms, and a dining room and bedroom. And participants were basically asked to describe the relevance of observing a given concept in, for example, a kitchen or in a dining room or elsewhere, right? And in case of the calorie data set, what is the relevance of finding ice cream in a highly calorific piece of food or diet, right? So people were asked to draw analogies to reconstruct those relations that they observed, right? Long story short, we recruited 100 crowd workers, 50 of whom worked on the calorie data set, 50 of whom worked on the places data set. Each participant worked on 6 tasks. So they were essentially asked to create 6 analogies. And once we gathered all of these analogies, we relied on 5 experts within the research group here who each worked on annotating the quality of dimensions on that set that I showed you earlier on. And we also ensured that there was an overlap to estimate the agreement. Because of the amount of time we have over here, I don't want to go too much into detail talking about the templates, but this annotation task was also supported by templates that the participants, the non-expert crowd workers could use. Let me just dive into what we found and what that tells us about this process of creating and generating analogies that could then be used in downstream tasks. Well, what we did find was the perceived helpfulness was quite indicative of how good our identified dimensions were. So we actually found that there was a pretty reasonably strong rank order correlation between helpfulness and the Likert-based dimensions that we considered, right? So this basically shows that if we ensure the generated explanations are of high quality across these dimensions, then they have a higher likelihood of actually being helpful in end users understanding exactly what is being explained over there, right? So better quality analogy can lead to a higher perceived helpfulness. Now, there were also differences between the two tasks and the data sets that we considered and the nature of analogies that resulted from that. For example, the explanations that were generated using the places data set had a higher relational similarity than the ones that were generated from the calorie data set. And this is probably because of the fact that the relationship between a concept and a label, right, like a kitchen or a dining room, is just more relationally explicit than in the calorie data set, right? Where if you imagine that there's some chocolate, well, chocolate's indicative of highly calorific diet, but it's a little more, it's a little less spatially relational in that sense, right? So the nature of analogies obviously are quite different. What are some of the key things that I'd like to leave you with before I wind up? Well, the fact that we observed a bit of disagreement amongst the experts, right? I didn't talk much about those details. I ask you to take a look at the paper, but we found that there was disagreement amongst the experts. But much like in several other works where disagreement can sometimes be a signal for improvement as opposed to noise, we realized that this disagreement could also be due to a lot of subjective factors that go into understanding analogies and interpreting them, right? There are user factors, there are common sense related backgrounds and domain knowledge that could all play a role. And what we essentially figured out was that, well, there's no single explanation that's going to fit everyone, right? And there's an opportunity here for personalization. When it comes to the generation of analogies itself, it's using this process that we orchestrated. It can be challenging for humans sometimes in the absence of cues to generate more and more analogies, right? People are quite quick to come up with a handful of analogies, but if you say, hey, generate 10 of them, and it gets a little more difficult. So there is an opportunity for creating more creative ways of generating analogies in a given session. There's also scope to come up with several hybrid ways of generating analogies and evaluating them. But I think the major takeaways here, let me dive onto that slide with an eye on the clock, is that one could also try and power common sense knowledge, combine that with analogy-based explanations while trying to personalize them to try and help users interpret AI advice. What we have here in this initial piece of work is a nice and structured set of dimensions that can be used to evaluate analogy-based explanations and a method that allows us to generate them. And all of this is freely available at our code repository over here. Just to wind up, I think that crowd computing offers a promising means to overcome fundamental challenges in both the computational and the interactional aspects of interactions of humans with AI systems. And I think this can lead to a new breed of human-centered AI systems where we often think about the end users at the core of the problem. So with that, I'll wind up and